In this series, we're going to take a look at some basic stats concepts via the lens of R programming. So we're going to practice stats and working with R at the same time. And today's topic is standard deviation. Standard deviation is a measurement of how much variation we have in our data. Specifically, how much do numbers differ from the mean? For a hypothetical example, let's imagine we had some student test scores. And I've worked up a very basic demo here where I created two sets of test scores, scores A and scores B. I set them to be a vector in R using the concatenate function. And in scores A, what we see is a group of very similar numbers. They're all within about 10 points of one another. Whereas with scores B, there's a greater range. Our min is 25, our max is 100. The numbers just bounce around more. And so when we run a standard deviation calculation on these two sets of scores, it should capture what we're observing here, where there's a higher standard deviation score for scores B than for scores A. To very quickly see this, let's have R tell us what the standard deviation is. We're going to use the built-in function SD. And to begin with, we will pass it scores A. And let's wrap this in a print function so we can see the output down in the console. We'll do the same thing for scores B. And then I'll click source to run all of this code. And then here in the console is our results. So as expected, scores B had a higher standard deviation value compared to scores A, just capturing that variability that we can very clearly see. So obviously calculating standard deviation in R is super easy with the ST function, but it's always useful to pop the hood and understand what's happening behind the scenes to really understand what standard deviation is measuring. And to do this, we're going to essentially reverse engineer the standard deviation function. We're going to calculate the standard deviation ourselves, but we're going to take advantage of some built-in R methods to do this. To accomplish this, I'm going to go over to the notes that accompany this video, and I want to scroll down to this section for manual calculation so we can look at the formula for standard deviation. Now, there's two variations of this formula depending on whether you're looking at the data of an entire population or just a sample. For our purposes, we're going to focus on the sample calculation, and I'll talk about why in a moment. But zooming in on this formula, the first thing we're going to do is for each of our data points, which is represented in the formula via x sub I, we're going to subtract the mean, represented by x bar, and then for each of those values, we're going to square them. So the first thing we have to do is calculate the mean for our data. And in R, we can do that using the mean function. So I'll say mean of scores A. Let's go ahead and capture this in a variable. And then print it out to our console. Then I'll run those two lines. So we can see our mean is 92.2. Now we want to take that mean and subtract it from each of our data points in score A. And the way we can do that using vector operations in R is we can simply say scores A minus our mean. And what R is going to do is it's going to take that mean and subtract it from each of these values in the scores A vector. And once again, let's capture this in a variable. So we're going to say diff from mean. We're going to be setting it to the result of that expression. And let's also print it to the console. So we'll run our calculation and then print our results. And you can see the result is a numeric vector for the differences for each of the numbers minus our mean. And just to see this and make sure it's calculating it correctly, let's imagine we were doing this manually. So if we took 98 and we subtracted it from our mean, which we know is 92.2, we get 5.8. So that matches our first number. Let's do it for the second number as well. So we're going to say 89 minus 92.2, and we get negative 3.2, and so on down the line. So checking in on our formula, we calculated the mean. We subtracted that mean from each of our data points. And now we need to take those values and square them. So once again, we can take advantage of vector operations. So we're just going to say our diff from mean, which remember is just this numerical vector, and we're going to square it. So we're going to say raise it to 2, and let's again capture this in a variable. And output it to the console. And once again, this yields a numeric vector. And let's just manually check it again. So remember, we were taking these numbers and squaring them. So if we were to take 5.8 and just manually square that number, we get, as expected, 33.64. Our next number is negative 3.2. So we want to square that. I do want to wrap it in parentheses, though, before doing the squaring. Otherwise, it's going to square 3.2 and take the result and make it a negative. But we don't want that. We want it to multiply negative 3.2 by negative 3.2. And just as we got in our numeric vector, we get 10.24. So checking in on our formula, our next step is we want to sum all of those values. So let's say our sum of squares And we're going to use R's sum function and just pass it our squared differences from the mean. And then let's see what that gets us. All right, 94.8. Now for that value, we want to now divide it by n minus 1, where n is the number of data points in our sample. So we'll take our sum of squares divided by n minus 1, and to get n, we're going to use R's length function. So we want to know the length of scores A minus 1. And let's capture this. What we're actually calculating here is something called the variance. So we're going to set it to a variable called variance. And this error occurred because I tried to print variance before I actually ran the line that set variance. So I corrected that. And we can see our variance is 23.7. And now the final step to derive the standard deviation from that is we're going to take the square root of it. So we'll invoke R's square root function, that's sqrt, of our variance. Print that out. And perfect. That number should look familiar because that was the number we got when at the very beginning we asked R to just tell us what the standard deviation of scores A was. And just to confirm that, I will print this to the console again and just definitely check that those two numbers match. And just to make sure we're clear on the big picture of how the standard deviation calculation works, let's recap by going back to the notes. I have step by step each of the steps that we took, beginning with taking our set of numbers and calculating a mean. So we added up all our numbers divided by the total count of numbers. That got us 92.2. We then took that mean and subtracted it from each of our numbers. And then we squared the results of those values. Then we summed up those squares. That got us 94.8. We divided that by n minus 1, where n was our number of scores. So that was, in this case, 4. That got us our variance of 23.7. And then finally, we took the square root of that to get our standard deviation of 4.87. And fortunately, because of the magic of technology, we don't have to do these sorts of manual calculations by hand. Obviously, that st function in R is very convenient. It makes our lives very simple. But again, popping the hood on these functions and really understanding how they're working can be really useful for understanding the statistics side of things and also just understanding what R is doing behind the scenes. And actually speaking to that, I want to jump back. So when we looked at these two formulas, I talked about how we were going to be focusing on the sample formula that used n minus 1 rather than just capital N. And the reason we went with the sample formula is because this matches what R does with their standard deviation function. Obviously, depending on the data you're using, whether it's a population or a sample, that would dictate which formula you're using. But for our purposes in our example, we wanted to match the built-in st function, which if we go over to R and we have it tell us about this function, so I'm just going to do $sd. That's going to open up my help pane. And if we look here under details, you can see that it uses the denominator of n minus 1. So we just wanted to make sure that we were consistent with that. Obviously, if you are doing calculations of the standard deviation for a population, you should be aware of that. If you use the SD function as written out of the box, that's not going to give you the calculation that you want. So one of the things you could do in that situation is actually come up with your own custom standard deviation function that you write in R. And in fact, this is a great opportunity to practice with custom functions. And in my next video, I'm going to talk about that. I'm going to look at how we can create a function out of the code that we've written and make it adaptable so it could work with either a population or a sample. So check the description when that video is published. I will include a link that you can follow there.